Hello, Year 10. I hope that you're doing alright so far, and I hope that you are coping and managing to keep up. Today, we are going to continue our look at inequalities. This is Inequalities Lesson 6, and what we're going to be trying to do today is the opposite of what you've been doing in the last couple of lessons, where in the last couple of lessons you have been given an inequality and you have been drawing it. Today we are going to have the diagram and we are going to figure out what the inequality is. Now, a lot of this work links into knowing how to name the equation of a straight line, which I hope for vertical and horizontal lines should not be a problem at all. Could be an issue for some of the diagonal lines where we need to calculate gradient and intercept, and it might be that you decide to watch a Corbett Maths video on gradient and intercept, which I'll put in the description below. So we're going to go through each of these questions. If you want to draw them out, you can. I will have included a link to a PDF copy of my page from this book, so you might just decide to either print mine or copy from mine. You don't really need to do it as the video is going on. So we're going to look at 4 questions in turn. We're going to start with 2 hopefully slightly easier examples and then move into something a little bit trickier. So this first one here, you can see I've got a vertical line. Now, I think the best approach to finding the equation of the inequality is to just start by writing down what the equation of the line is. So, since this is a vertical line crossing the x-axis at 4, I know the equation of this boundary, this line, is x equals 4. So I know the inequality must involve x, a 4, and a different symbol in between. And now it's just a case of working out which symbol it is. And we've only got 4 choices: greater than, less than, greater than or equal to, less than or equal to. So if push comes to shove, you could have a little bit of a guess, but let's see if we can figure out which one it actually is. Now, you should remember from the previous 2 lessons there are rules about the dashed lines, or the broken lines as Mr. Corbett calls them, or the solid lines. Remember, if it is a solid line, you've got the extra bit there, it includes the equal to. If it's a dashed line, it doesn't. So I can see in the shaded region, all of the numbers this side are where x is less than 4. Because it is a dashed line, that also makes me know that it is less than 4. So I can now just change that. So the final answer, that x is less than 4. So it's really, really important you have a good understanding of which way your inequalities face. So that is the first question done. Let's have a look at my second one. Now, you might have seen me refer to these sorts of ideas as a closed region. So it's going to be trapped by 2 inequalities. There's going to be an upper limit and a lower limit, a little bit like the work that you've done on bounds. Now, again, I'm going to start with the numbers or the equations of the lines that I know these are. So this one is a horizontal line cutting the y-axis at 5. So that line is y equals 5. And the one below it is y equals 2. And we can see all of the y values are the numbers in between 2 and 5. This is a solid line, so this is going to include the equal to, and this is a dashed line, so it doesn't. So I need to say that it's a closed region between 2, including 2, and 5. And you might recall that in a closed region, the inequalities always both point downwards. Okay, a little bit like when you're grouping data in a group frequency table, or you're creating a cumulative frequency graph. Okay, now I would refer to those ones as the easier ones. If it's vertical and horizontal lines, those shouldn't cause any problems because you can immediately look at the line and think, I know the equation of that line. And you'll probably find that some of you are better than others at just looking at a graph and immediately knowing what its equation is. Okay, other people might need to work out the gradient and the intercept, so I will go through that process in my next two questions. So I'm just going to adjust the camera so we can see the other two. So both of these are diagonal lines, so they are going to involve a little bit more thought. Now, if you think you already know what the equation of this line is, great. See if you're right when I actually physically work it out. So, just like before, I need to know the equation of that line. And the way that I'm going to do this is we know it is a straight line graph, so it is y equals mx plus c. And I'm going to work out the value of m and the value of c, my gradient m and my intercept c. So I'll do the intercept first because that's easier. It cuts the y-axis at positive 2, so I already know that my equation of my line has a plus 2 on the end. Now, working out the gradient, you pick any points that lie on the line. I'm going to pick these two, and we form a little triangle. And the formula for working out the gradient is the change in the y, and this is 2, divided by the change in the x, and on this one it is 1. So my gradient is 2 divided by 1, which is 2. So the whole equation of this line is y equals 2x plus 2. So now we need to figure out what inequality it is. I know it's a solid line, so that means it includes the equal to. So we know it's one of two choices. Is it greater than or equal to? Is it less than or equal to? And the easiest way to do this is pick a point that lies in the region and try and then substitute the numbers to get the inequality to work. So I'll show you an example of this. I often like picking the number 0, 0 because it's easy to substitute, but that doesn't lie in the region. So what I'm going to do is I'm going to use this coordinate here. I'm still keeping one of the numbers as 0. And this coordinate is 0 along the corridor, 6 up the stairs. So x is 0 and y is 6. So I now take my equation, y equals 2x plus 2. I now substitute my numbers in. Y is 6. I'm going to not put the equal sign in now because this is not going to equal when I substitute my numbers in because it doesn't lie on the line. I'm now doing 2 of my x values, and this is why I picked 0 because it's easy then. 2 zeros is nothing, plus 2. So I've got 6 on one side and 2 on the other side. And if you want to do your naughty crocodile, you can. He would eat the larger number. 6 is greater than 2, but it is a solid line, so I'm going to need to include the equals. So my final inequality is y is greater than or equal to 2x plus 2. Okay, so 3 down, 1 last one to go. And now 1 or 2 of you will have already spotted something about this graph. It slopes the other way. It's going to have a negative gradient. Some of you, I would hope, would be able to tell me immediately what that gradient is because of the way that this line is sloping along that perfect diagonal. But we'll still work out the equation of the line in the same way I did the last one. So we've got y equals mx plus c. I can see my intercept is 4. So I'm going to put a +4 on the end. I think the sensible 2 points to form my triangle are these 2 points. And then my triangle would be this here. So it's going to be 4 divided by 4 for my gradient, which is 1. But it's sloping the other way, so it's a negative gradient. So the gradient is -1, so the equation of this line is y equals -1x plus 4, but I can just write -x. I personally would actually rearrange this equation slightly and move the negative x to the other side, and you end up with actually the equation y plus x equals 4. Okay, so there's going to be a little bit of variation maybe in some of your answers. If you don't do that, I will try when I'm producing some questions for you to do, if there's any questions that are a little bit like this, maybe give you both answers. But we've not quite finished because we haven't sorted out the inequality. So I'm just going to use the same point as I used last time. When y is 6 and x is 0. So I'm going to do my little substitution into here, but I'm going to drop the equals sign. When y is 6 and x is 0, 6 plus 0 is something related to 4. Well, 6 plus 0 is 6, and that is greater than 4. So my final inequality should be, swapping that sign out, y plus x is greater than 4. Does it include the little equals to? No, it doesn't, because this line is dashed. So, like I said, folks, there'll be a copy of this if you want to just print it out. I do realise some of you have issues with printers. I'm doing the best that I can in terms of trying to give you resources that you can print out if possible. If not, I'm afraid you'll just have to copy things into your book. Okay? So, good luck with the questions. If you like me doing these videos, do drop me an email and let me know, because I'm more than happy to do so if you think it is better. My philosophy is, if Mr. Corbett has done something that is fit for purpose, then I will use what Mr. Corbett has created rather than create something new that pretty much says the same thing. So, for the time being, folks, that's it from me. Signing out. Goodbye.